Good afternoon, student. Let me intro myself. I am Lauren Justin. Now I am working in JPR University at Chennai. Let me give some information about the water technology. Before seeing that water technology, everyone should know what is the importance of water. We know very well water is a very important thing to all the living species, animals, humans, plants. So not only that living species, almost with the help of the water, we are always running our life. I'm telling about the industries. So, in which domain the water is most probably used in our life? For example, if you are taking for the living species, for example, human life, we are using the water for drinking purpose, cooking purpose, washing purpose. So, directly or indirectly, we are using the water. Another one, intaking the water content for growing our organ. So all the organs which is available in our body is always need more and more minerals. That minerals are supplied by the water because the water is having more minerals compared to other solid foods. Another one, animals and plants also need the water for their growing. Especially plants need the more content of water for their growing as well as their photosynthesis process. Now come to the another domain, that is non-living matter. That is always our human activities includes of domestic activities, agricultural activities, and more than industrial activities. Domestic purpose, we are using the water in our home for washing purpose, cleaning purpose, and so. In agriculture, almost water is used as a irrigation purpose. In industry purpose, we know very well water is used as a cleaning purpose in industries. Not only that, in industries, it is almost use the water as one of the fuel. When you are going for the fuel, you are always thinking about fossil fuels, maybe petrol, diesel, and so. Apart from that fossil fuel, water is always using more content of almost all the industries as one of the fuel. How it is possible? Yeah, is it possible first? Yes, it is possible. Water is used to produce the steam. That steam is used one of the fuel in almost all the industries. For example, you may consider any of the industries. If industry needs more temperature, more heat, if you are using prolonged time of the petrol or diesel or fossil fuel or any other, it's very impossible because their abundance are very low. Their cost also very high compared to water. That's what almost all the industries are focusing the water for their fuel purpose. So what are the sources of water? Water is existing in three forms in our world. One is the surface water, second one is underground water, and last one rainwater. Almost everyone knows about the rainwater. This is a cyclic process. Water is available in our surface in the form of river, lake, sea, ponds, and so. Not only that, and also from the bodies of living species. So that water is always evaporated. Then those are gathering in the form of gas in our atmosphere. Then it is producing rain. Hello. Now, underground water, the water which is contained under the ground. Sorry for the inconvenience. We will start the section. So underground water, that is nothing that bore wells, there also water available. We are taking out the water, sucking the water from the underground also for our regular purpose, regular uses. Now, in this whole level, one of the statistics told, agriculture sector is always uses 70% of water from our abundant nature. Industrial things also use 20% of water. Compared to agriculture, it is a very less thing. Apart from H2O, that nature is called a impurities. Apart from H2O, what are the things are available? Almost organic content, inorganic contents are available. What are the inorganic and organic contents are available? All those things are available in water. Why it is happening? Why it is always existing in the water? Because of water is acting as a good solvent. Everyone knows we are using the water for cleaning purpose. Why the water is always choosing as a first priority to clean? Because it is a very good absorber of all the stain, all those materials. That is the reason for we are selecting the water as a one of cleaning agent. So water can dissolve almost most of the chemicals like inorganic and organic. Based on that, we are giving the name dissolved impurities, suspended impurities, microorganisms. So dissolved impurities are nothing just like a salt in nature. It may be organic salts or inorganic salts. All type of salts will be dissolved in water. Then they are existing in water. That water is called as a one of impurities in water. Suspended particles means they are also dissolved, but they can't be visible by our eyes. Those type of chemicals also available, like organic, inorganic impurities. Not only that, sometimes oil particles also available. Microorganisms are nothing, living species, small living species are available like bacteria, fungi, and algae. Now, water can be classified by two types based on the presence of ions, or impurity of water can be classified two types: hard water, if it is not impure nature or some other nature, may called as a soft nature. This is just people are always thinking like that, but it's not a real thing. Water can be classified hard water and soft water. If you are hearing the word hard, means it's not a giving the very tough in nature, very strong in nature, not like that. Based on the salt present in the water, we are giving the name hard water and soft water. Hard water is nothing, the water which is existing with calcium and magnesium. So whatever the salt nature of the calcium and magnesium present in the water, that type of water is called a hard water. For example, you may consider calcium salts of chlorines or magnesium salts of chlorines or calcium magnesium salts of sulfates, carbonates, bicarbonates, and so on. So the salts majorly having calcium and magnesium as a cation. If it is available in water, that type of water is called a hot water. Why it is called a hot? Because of those water cannot produce the lather with soap solution. Because if you are using the soap while washing the clothes or your hands, sometimes the water, some of us are producing more foams. Sometimes water won't be produce the foams. What is the reason? Because of presence of calcium and magnesium salt. If the calcium and magnesium salt, it is having calcium or magnesium salts. When the calcium magnesium salts present in the water, it is treated with soap solution. Here nothing, sodium stearate. When the sodium stearate reacts with calcium or magnesium salts, they are replace their cations and produce calcium or magnesium stearate. They are precipitated in form. They are the solid in nature, they are not dissolved in water, so they are producing precipitates. So they won't give any foams. But instead of that, if calcium and magnesium are absent in water, if you are treating the soap with that water, they will produce stearic acid. That stearic acids are foaming nature. That's what they are producing more foams. That is in soft water. Then again, the hardness of the water can be classified by two types based on the ions presence. Commonly, calcium magnesium salts we represented earlier. What type of calcium magnesium salts are responsible for temporary unhardness? Now we are going to see. So, calcium sulfate, calcium chloride, calcium carbonate, calcium bicarbonates. Those are the major salts responsible to produce hardness of the water. Among this, only bicarbonate salts are giving temporary type of hardness. The name itself, it is explaining temporary. This is not a permanent hardness. Temporary means if we are giving any interaction or any small disturbances, immediately it can change. That type of natures are called a temporary. So here also we are using the word temporary because if you are giving small interaction like boiling the water, that bicarbonates are easily escaped. So these type of hardness are called as a temporary hardness. So temporary hardness is only the causes of bicarbonate salts of calcium and magnesium. The remaining salts always giving the permanent hardness. That is nothing calcium magnesium chlorides, calcium magnesium sulfates, sometimes alum also. They won't be easily removed by the boiling. That's what this is called a permanent one. If you are giving the small interaction, small troubles, they won't be changed as a soft nature. That's what this type of hardness are called a permanent hardness. Then the degree of hardness is not much of important, but anyways, people should know. Uh, hardness can be expressed in the form of ppm with the help of calcium carbonate. Why we are using the calcium carbonate for choosing to express their hardness? Because of the calcium carbonates having the whole number of their equivalent weight. They are having 50. Their molecular weight is 100, equivalent weight is 50. So molecular weight divided by their oxidation state, that is called the equivalent weight. That's what the hardness of the water can be expressed with the help of calcium carbonate in nature. Now, directly we will go to the characteristic studies of water. First of all, water is always existing lot of characteristics: solubility, turbidity, chlorine content, arsenic content, alkalinity, and so. Among this, in your curriculum, it is having only two things, that is alkalinity, another one hardness. First, earlier we saw about the hardness. Now, how the hardness is going to determine? Let me tell something about the determination of hardness with the help of EDTA method. EDTA is nothing, is one of the chemical. It is having the abbreviation of ethylene diamine tetraacetic acid. Once again, I am telling you, ethylene diamine tetraacetic acid. Ethylene diamine tetraacetic acid is a water insoluble. So, we will take any of the salt of ethylene diamine tetraacetate for the determination of hardness. So, how it is determined? Say, by visibly, it's difficult to say whether water is having hardness or softness. If you are adding the soap solution, that time we can predict what type of water is there. If it is producing the foam, it may be considered one of soft water. If it is not producing the foam, instead of forming the foam, if it is giving the precipitate, white precipitate or scum, that type of water may consider hard water. But how that hardness will be determined? With the help of soap solution, we going to give the quantitative analysis of hardness of water. For that, we need some other process, that is titration method. Let me give something introduction about the titration. I hope everyone has completed the titration during your 12th standard with the help of burette, pipette, conical flask, and indicators, so on. So in conical flask, you are pipette out some of the 20 ml of the solutions. In burette, you filled with some of the solution with 50 ml. Thereafter, some of the indicators sometimes will add, sometimes won't be add. Why? Because of some of the chemicals are acting as a self-indicators. It may be in color in nature. So the titration, during the titration, burette solution will be added drop by drop to the conical flask solution. Then the color will be changed. At the time of color change, we are stopping to adding of burette solution. Then the reading will be taken. The same thing, similar thing will be applied for here. But here some of the solutions are changed. In conical flask, we are going to take the water. That is the sample water. Water which is going to test it. Whether it is hard water to form one of the one of the complex. Here hard water, if it is hard water, it is having calcium and magnesium salts. That calcium magnesium salts can use to produce complex. To form the calcium magnesium complex, we need one of the medium, whether it is acid medium or base medium. We are having those. Especially calcium and magnesium salts can easily produce the complex only in base medium. So we need to add buffer solution here. So acid medium means we can use acid type of buffer. Base medium means we should use only base type of buffer. So we are going to take weak bases like ammonium chloride, ammonium hydroxide, ammonium hydroxide, or some other ammonia directly. So ammonia will be taking as buffer solution. So buffer solution will be added in conical flask. Automatically it is maintaining their pH level. We are adding base buffer solution, especially weak base buffer solution. So the whole content of the conical flask will be maintaining base medium, especially weak base medium. Thereafter, if you are adding indicator, that indicator is nothing EBT. It reacts with calcium or magnesium or both presence in the water. It producing some kind of color, that is nothing wine red color. Just see the principle. EBT reacts with metal ion. Here M represents metal, is nothing calcium or magnesium. That calcium or magnesium reacts with EBT to produce EBT metal complex. This is a weak complex, that is unstable in nature. The color of complex is wine red in color. I hope you have completed in your practical section. This is the EDTA method. Determination of hardness in EDTA method in your chemical laboratory. Now, by adding indicator, we are getting wine red in color. It indicates that water is hard water. If you are adding the water, it won't give the wine red color, means that water should not have any hardness. It means it is not having a calcium and magnesium or absence of calcium and magnesium simply. So if the water is having calcium magnesium salts, definitely it is producing unstable or weak complex of metal EBT, calcium or magnesium EBT. That complex color is wine red in color. Thereafter, that formed complex is reacts with EDTA, that is which is filled in our burette solution. Now, when you are adding the EDTA will act as a ligand. Initially, that indicator acted as a ligand. That's what they are producing the weak complex. Now we are going to add EDTA. Here EDTA also having the capable to acting as a ligand. Compared to EBT, EDTA is strongest ligand. So it is easily replace the EBT from that complex. So initially calcium or magnesium EBT complex formed. After adding EDTA, all the EBTs are replaced by EDTA and then it is newly forming the calcium or magnesium EDTA complex. That color of complex is nothing, it's a colorless complex. That complexes are strong complex. Why it is called a strong complex? Because that EDTA is a strong ligand compared to EBT. So all the EBTs are replaced from the complex. Then still EBTs are available in the solution, that is conical flask solution. Their color is steel blue in color. That's what the color of the conical flask content is turned to wine red to blue color. When it is started, we will start to add of EDTA, then that point will be noted, that reading will be noted. With the help of that readings, we can easily calculate that what is the hardness is present. Here two type of hardness already I told you, that is temporary hardness, another one permanent hardness. For calculating temporary hardness, first of all, we need to calculate the bicarbonate quantity. For permanent remaining quantity, we want to calculate. So two type of water sample will be taking for determination of hardness of the water. So first of all, we should prepare the standard hot water. What is the meaning of standard hot water? Why we are using the name standard? The standard is nothing known volume or value. Here, almost the titration process, we are using the standard only for known concentration solutions. So, the known concentration standard water will be prepared. Then, with the comparison of standard hot water, we are going to calculate, determine that hardness of the water with the help of boiled water, another one raw water. If you are having the boiled water, it is giving permanent hardness because the boiled water is always remove temporary hardness. So boiled water will give the temporary remove, that is permanent hardness. If you are taking the normal water, it will give total hardness. From the total, if you are substituting the values like subtract, automatically we will get boiled means temporary hardness also. This is the method we are using. Now directly we will go for industrial life. Water is used in most of the industry purposes. In food industry, poor quality water is responsible for diseases. If the water is having hardness, if you are using that type of water for preparation of any of the food, when we are consuming that food, it is giving a lot of diseases. This is the one of the problem arises in this world nowadays. Another one, and main of the water, mostly it is having a microorganism. Without treating that water, if you are using the water to produce any of the food content, automatically it is giving some kind of dangerous disease also. Okay. This is happening in food industries. In textile industries, almost you may consider fabrication process, that is dye industries and so. So there, if you are using the hard water, they won't give the proper dyeing nature to the materials. Automatically, the dye is going to fade very short time thereafter our spent money is almost waste. And not only that, and also some kind of organic matters, some inorganic matters like iron, manganese is also available in that water. They are trouble to give pure nature of textile industries. Another one, pharmaceutical industries. Pharma industries is nothing. This is one of the industries to produce more drugs to rectify our diseases. So for preparation of medication, we need a pure water. If you are using some other dirty water or hot water or some other mixed nature of water, they are giving pathogenic problem. Then sugar industries. When the hot water is used, it is giving very worst nature of the sugar. Okay. Then it is very difficult to give the crystals. Instead of sugar crystals, we can get non-crystal amorphous natures of sugars. In paper industries, their silica contents are mostly absorbed. There should be used free nature of silica and some kind of metals. Now we will go to boiler. Already I told you water is used as a fuel. Water will be converted as a steam. Then it is giving one of the fuel form. The steam is used as a fuel in almost all the industries. For producing the steam, we need the boiler. Before starting the boiler, everyone knows about the tea shop. In the tea shop, they are having one of the boiler with the brownish color, just like a cylindrical vessel. There, they are using the charcoal to produce the heat. One tap is available there. When the tap is open, water is coming with very hot in nature. Similar principle is applied in the boiler also. Here the boiler is nothing. Water will be added continuously. Then that water is heated. Then it is converted to steam. The steam which is coming out from the boiler is always supplied to almost all the plants which is available in the industries as a fuel. Here, if you are using hot water, we are facing lot of problems. The boiler, especially the boiler, is having lot of problem. That one, first carryover. Carryover is nothing, formation of priming and forming. Another one, boiler corrosion, caustic embrittlement, formation of scale and sludge. We will discuss about one by one. When those type of troubles are happening, when the hot water is continuously feeding into the boiler. The boiler is one of the device which is used to convert the water as a steam. If we are feeding pure water, that is a soft water, the boiler won't have any problem. Instead of soft water, if we are adding hot water, that time they are facing troubles. That troubles are called boiler troubles. People will ask the question, why we are supplying the hot water instead of soft water? If you are adding the hot water, it is having the trouble, we know that. Then why can't we go for soft water? Why? The abundance of the soft water in this world is very, very low. Very, very less percentage compared to hot water. That's why hot water to be treated, then it will be added to the boiler. Suppose that process are not insufficient, automatically hot water is directly or indirectly fed into the boiler, then it gets this type of troubles. First of all, priming and forming. Here nothing. When the water is continuously feeding into the boiler, sometimes the steams are coming outside is not a pure in nature because of hard in nature. The calcium, magnesium salts are not only the calcium, magnesium, almost remaining salts. The content which are available in the water always trouble to boiler. Here, priming is nothing. Dissolved salts are come out in the form of precipitates when they are reaching their satisfaction nature. Sometimes the boiler operator will check whether steam is continuously coming out, whether it is sufficient quantity supply. If we are continuously supplying the boiler hot water in boiler, that time the production of steam will be decreased. But the operator don't know whether the water is treated or whether it is soft water. He might thought, okay, our applied temperature is not enough. That's what the steaming levels are decreasing. So suddenly he will increase the temperature. He will raise the temperature. That is one of the reason. So automatically the velocity will increase. Another one of the reason, he thought the supplying water quantity is not much, so the steam is coming very low. So suddenly he will increasing the level of water. This is another problem. Next one, priming. Priming is nothing. The water droplets are coming out with the steam. The steam is purely gaseous status, but sometimes that's gas particles are existing along with some kind of wet nature, that is liquid nature. That is called a prime. So how it is happening? A rapid increasing the temperature and maintaining low boiler. So in boiler we should maintain particular level, not much more, not much low. So if we are violating this, automatically the steam is coming out with some of wet or droplets. That is called a priming. It will be avoided. Then foamings. Foamings are nothing. Stable bubbles are formed on the surface of the water. Why it is happening? Because of presence of some oil contents or grease contents in that water. You can do one thing in your home. Take a water in a bottle and add 2 or 3 drops of any of the oil. It may be coconut oil or ginger oil. Then add the water and shake it. Automatically they are producing the foams on the top layer of the water. The same thing happens inside the boiler. This is another problem. Why it is happening? Because of presence of oil and grease. We are not taking the oil type of water or grease type of the water directly, but for the protection of device, it is having some kind of oil content as well as a grease content, especially in the rivet. So that rivet pots are having some kind of greases. It should be properly removed or cleaned. So all those things are giving waste of heat, waste of time, boiler efficiency will be decreased, then it makes a corrosion. These are the disadvantages of priming and foaming. Another one, boiler corrosion. So corrosion is nothing just like erosion. Some of the particles are responsible to erode the material of the boiler. Those things are called boiler corrosion. That chemicals are nothing dissolved in nature, some oxides and acid. So dissolved oxygen, carbon dioxide and acids which are dissolved in water. Those waters are directly fed into boiler, those boiler corrosion happens. Now we'll consider about the dissolved oxygen. The oxygen directly dissolved in water, then it is feeding into boiler. When it is reacts with iron material which is made up of the boiler, will react to produce iron oxides, iron hydroxides. Finally, it is giving the rust. We know very well the iron particles are reacts with water and then produce the rust. Rust is nothing, ferric oxide of water. So it is a slow process, very slow process reaction. But the boiler is continuously using one of the devices. Continuously water is feeding into the boiler to produce a steam. Without that, the running of industries is very, very impossible. So this is a continuously running. Automatically rust is forming. When the rust is forming vigorously, what will happen? The boiler is going to explode in nature. So how it is going to remove? By adding of sodium sulfate. By adding of sodium sulfates, that oxygen will be converted to sodium sulfide. So automatically the dissolved oxygen will be absorbed by sodium sulfide. This is one other method. One another method by using of hydrazine. If you are adding the hydrazine, just see the second reaction, N2H4. N2H4 is nothing, hydrazine. When you are adding the hydrazine, it is producing the product of water as well as the nitrogen. Nitrogen is almost inert in nature. Chemically, it is inert nature. So the second process is almost preferable to remove the dissolved oxygen in almost all the industries to treat the water. Another one, sodium sulfate. Adding of sodium sulfate will give the sodium sulfate. So the oxygen will be absorbed. In all these reactions, the dissolved oxygen will be converted to some other compound to avoid boiler corrosion. Next one, dissolved carbon dioxide. If the carbon dioxides are present more content in water, it will produce bicarbonate salts or carbonic acids. This is one of the acid nature. All the acids are having corroding nature. It is going to corrode the materials which is made up of boiler. So it will be easily removed by magnesium bicarbonates. When the magnesium bicarbonates reacts with carbon dioxide, then it is producing more salt. Ammonium hydroxide will be reacted with carbon dioxide water, then they are producing ammonium carbonate. So dissolved carbon dioxide can be easily removed by adding a weak base like ammonium hydroxide. Then it is highly volatile nature at a higher temperature, because water is always having the more temperature inside the boiler. That ammonium carbonate will be easily removed. Then another process, mechanical deaeration. The mechanical deaeration is nothing, is one of the process with the help of another device. So here the towers are having some perforated plates. They are having higher temperature in nature. When the water is feeding or passing through the plates, their easily volatile nature of chemicals will be easily removed. So aeration is nothing, adding of air is called a aeration. Deaeration means removal of air. So that principle is applicable, available in water. Then it is producing hydrochloric acid. The hydrochloric acid, all the acids are corroding nature. How the acid will be prevented? Acid can be neutralized with the help of adding of any of bases. Okay. Another one, addition of inhibitors. And blowdown operation also help to remove the acids. Softening of boiler water. Only the way hot water can be converted to soft water, then we will use in boiler. Automatically those boiler corrosion, boiler troubles will be removed. Now caustic embrittlement. The caustic embrittlement is nothing but the brittle nature of boiler compounds. So boiler air gaps. just like a cracks. In the cracks, small particles are going and occupying the place and accumulated there. Then it develops that cracks. It becomes very dangerous to boiler. That is exposed. So intercrystalline cracking of boiler materials is called a caustic embrittlement. The words are very important. Intercrystalline cracking of boiler materials. How it is happening? Some of the crystals are occupying that minute air gaps. Then they are extending the cracks. Automatically, brittle nature of boiler change. For example, sodium carbonate. Prevention method. Sodium carbonate phosphate will be used instead of sodium carbonate. See, this is one of the process which is used to softening the water, treat the water of the hard water. The hard to be converted to soft water. Some of the chemicals will be added initially. One of the compounds, sodium carbonate, will be added. Instead of adding of sodium carbonate, may use of sodium phosphate. This is one of the remedy action we can do. Okay. Another one, by adding of tannin and lignin. By adding of tannin and lignin to the boiler water will block the cracks available in that boiler. Then the boiler embrittlement will be prevented. Now, scale and sludge related to calcium salts, especially calcium sulfates. When the calcium sulfates are available more available in water, they are giving the precipitate inside the boiler. That precipitates are two types in nature. So one is very strongest nature, another one very loose in nature. Based on the precipitate nature, we are giving the name sludge and scale. So only the calcium salts. So the calcium salts which are giving soft precipitate, that is called a sludge. The hard precipitates are directly sticking on the surface of the boiler, then they are creating another layer. If it is automatically increasing their level, what will happen inside the boiler? It won't give the sufficient temperature to the water. The boiler efficiency is going to reduce and the production of steam will be decreased. The sludges are slightly different from scale. They are also the precipitate, but they are non-sticky in nature. Adherent property, based on the adherent property, we are giving the name scale and sludge. Scales are more adherent, sludges are less adherent in nature. And whatever, they are acting as a poor conductor, especially heat conductor here. Okay. How the scale formation, sludge formation will be prevented? By using a wells of water or blow down process. Blow down process means with the help of aeration, the precipitates will be moving from the top to bottom layer, then it will be easily removed. So now we will go for treatment of water. Before feeding, we can treat the water. After feeding, water can be treated. So two types of treatments are available inside the boiler. So inside the boiler, if you are adding the chemicals directly, that treatment is called internal treatment. Before feeding into the boiler, water should be treated. That type of treatment is called external treatment. The words very important: internal, external. Internal means inside, external means outside. Inside the boiler, directly some chemicals are added to convert hard water into soft water. That type of treatment is called internal treatment. Another word, internal softening. The first process, phosphate conditioning, carbonate conditioning, calgon conditioning. Another one, colloidal conditions also available. So phosphate, carbonate, calgon conditioning. Why we are using the word conditioning? With the help of this chemical, water is giving soft in nature. So the conditions of the water has been changed. So that's what we are using the name conditioning. In phosphate conditioning, we are always using sodium phosphate. Earlier I told you sodium carbonate will be adding one of the conditioning agents. Instead of the sodium carbonate, make use of the phosphate for avoiding intercrystalline brittlement process. So here the sodium phosphate, when we are adding the sodium phosphate, the metal salts are converted to all metal phosphate. They are insoluble in nature. It is easily removed by the filtration process. This is one of the process, that is nothing phosphate conditioning. Another one, carbonate conditioning. Here the sodium carbonate. This sodium carbonate, if you are using, if you are continuing this sodium carbonate, it is creating the problem, that is caustic embrittlement. Anyways, this is also one of the process to use convert the hard water into soft water. Here the sodium carbonate directly added to the boiler inside. Then the calcium salt are converted to calcium carbonate, which is precipitate in insoluble nature. So all those precipitates are settled down. It will be easily removed by opening the gate valve. And calgon conditioning is nothing, is one of the complex, especially hexametaphosphate complex. Sodium hexametaphosphate is called as a calgon, which is adding with boiler water will give the soluble nature of calcium salts. In previous process, that is phosphate conditioning and sodium conditioning, both the process they are giving only precipitate nature of the products, but here they are giving soluble nature of product. But we are almost using calgon process to convert this hard water to soft water. Hello, சொல்லுங்க. ஓகே மேம். ஓகே மேம். Next process, external treatment. So before feeding into the boiler, water should be treated. That process are called external conditioning or external treatment. Here deionization process or demineralization process or ion exchange process. So it is having three name: deionization process, demineralization process, or ion exchange process. So deionization or demineralization. First of all, ionization is nothing, adding of ions is called the ionization. Deionization just opposite of adding of ionization. So removal of ions from someone, that is called a deionization. Mineralization, adding of minerals. Demineralization is nothing, removal of minerals, that is called a demineralization process. Here cation anion exchange resins are used to remove all type of minerals from the water. So based on the functional group present in the resins, we are giving the name cation exchange resin, another one anion exchange resin. If the functional groups are acid group, that type of resins are called cation exchange resin. If it is base group or alkaline group, that is called a anion exchange resins. Okay, bro. Okay. 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 Focusing ion exchange process. Another one, reverse osmosis, that is desalination process, removal of salt content from the water, especially the common salts like sodium and potassium chloride salts from the water. We know very well about the RO process. We are always using the RO water for our drinking purpose as well as the purpose in our life. Very, very comfort nature of RO plants also available, or devices also now itself available in the market. We are using in our life also. Most of the homes it is available now. It's a very simplest process with the help of membrane, salt water to be converted to soft nature. So the very advantages we know very well. It is having more advantages. Which one? That is RO process. For example, all type of water can be easily treated here. Another one, membrane has the more lifetime. It's a very simplest process. It is always used at almost all the temperature nature, at lower as well as higher temperature nature. Then it is suitable to convert the type of water, it may be in salt or seawater, to drinking water. These are the advantages. Main disadvantages, maintenance cost is high. What type of maintenance? The replacement of membrane. But yearly once we are going to replace it. The backwash is very easy. So, but only the disadvantages of RO. So nowadays, how the municipal is treat the plant water. So initially, water will be taking and storing in suspended particles. Water is going to stand prolonged time without giving any disturbances. Automatically, the suspended particles are going to settle down. Next one, coagulation. Adding of coagulant is nothing by adding of alum. Till some of the suspended particles are available, that particles will be absorbed by the coagulant. Then it is giving precipitate in nature. These are the process. How it is absorbing by adding of coagulant. Then that coagulant will be absorb all type of impurities. Then they are settled down. Filtration, sterilization, everything you know. In sterilization, by adding of infectious agents, they are almost giving hypoxychloride. That hypoxychloride, one of the chemical, is very responsible to kill the bacteria. Then it will be supplied. So nowadays in RO plant treated, we are purchasing lot of water cans and water bottles also, including Aquafina, Bisleri, whatever. So those things are treated with UV rays and chlorination process. Applying the UV rays, bacteria are going to destroy. Another one, by adding of chlorines. Chlorine will be added by three process, either bleaching powder or chlorine gases or chlorine solid particles. By three phases, chlorine content will be added in the water. Then finally again it is going to filter. Selling in the market, we are purchasing those things. So you should know the breakpoint chlorination. That is a very important topic here. When you are adding the chlorine content, whatever it may be, either gas or solid in nature, initially the particles which are available in the water are absorbing the chlorine, then they are converting to their corresponding chlorine compounds. Then after that, all the particles are reacted with chlorine. There is no particles are available to react with chlorine. That time the formation of chlorine compounds are going to decrease. So initially from the curve A to B increases, then B to C decrease. It means A to B increases means the particles are high, so the formation of chlorine compounds are high. So it is giving increasing curve. When the particles almost going to reduce, the curve also is going to reduce. Finally, it is giving the null point like C. There, only the free radicals, only the free chlorine ions are available. So when you are adding more and more chlorine again, automatically the free chlorine content will increase. So the point C is called a breakpoint chlorination. At that point, no particles are available, no bacteria are available. Almost the water is always pure in nature. That point is called a breakpoint chlorination. Now going for the second unit. The engineering polymers. Nowadays, the polymers are playing more important role in almost human life. Whenever we are going to purchase the product, that is always combined with some kind of plastic. We know the plastic, but we don't know what is a polymer. Polymer is nothing. This is also another branch of chemistry. Now, the polymer is one of the branch of chemistry I told you, especially organic chemistry. Plastic is one of the polymer. So, whatever the products we are having, that product itself at least it is having at 1% of mixing of polymers. For example, you may consider the cooking devices, especially pans, the non-stick tawas. There, Teflon coated tawas are available, but we don't know. When you are seeing, it is just like a metal something, but this is a really polymer content. Another one, composites. The composites are nothing, it's now small constituents. Plastic along with some other metals. Plastic along with non-metals. So, if you are having the single compound, they are giving some kind of strength. If anything will be added to some other, automatically their strength will be increased. Their performance also increase. This is the reason to produce more composites products in this world. For example, once upon a time, the buildings are always constructed with the help of bricks alone. Nowadays, instead of bricks, plastics are used. Directly, plastic will be added, will be taking for constructing the building, even though they are giving more stronger compared to bricks, compared to ceramics. This is the one of the vast area used in plastic in our world. Another one, composites means glass particles. Almost, if you are seeing the IT field, IT park buildings, this is always having more content of very colorful and different colors instead of glass particles. We are thinking that is a glass. Really, that's not a glass, that is a composite glasses. The glass combined with plastic, then it is produced. This is one of the glass composites. So whenever the materials are mixed each other, automatically their performance increases as well as their strongness increases. This is the main reason nowadays industries are focusing these type of product. Not only the industries are focusing, why they are focusing? Because of people are expecting more and more. They are expecting with low cost, but they are expecting higher performances. Whatever the products we are going to purchase in our life, we are expecting that product should be in less amount, but their life should be more. The same principle all the industries are going to apply, only the way they are producing in the nature of composites. That is the main advantages of the plastics, especially the polymer. This is one of the industries happening nowadays. Another one, resins. Resins are mostly used in almost the products for sticky nature. Say at a higher temperature, the plastic contents are melted each other, then it will be combined to some other compound or constituents to produce more and more content of composites. During that time, some particles are not mingled each other and they won't be produce the homogeneous nature of the product. For that time, the resins are using to give the more strong nature between the composites which is having the constituents. So resins also used nowadays, especially polymer resins. This is the another important things using in our marketing places. Once upon a time, and now let me tell about something in that vehicle nature. Once upon a time, for example, you may consider the four wheeler, that is a car. Once upon a time, that particles of the car particles coming with only the steel or metal, sometimes non-metal. Initially, it is coming with iron particles only. Day by day, it was changed. Why it has been changed? Because of they want to perform very well. If you are using only the iron material, that whole product's weight will be increased. If the particle weight increase, they won't give more mileages whenever we are using or whatever the type of fuels we are using, whether it is diesel or petrol. The petrol engines are always giving more mileage compared to diesel engines. You may consider any of the car, especially the Ambassador, which is one of the oldest product, our Indian product. It is the best product in our world. In our marketing also, no one brandeds are beating still Ambassador because of their safe nature. Why? That Ambassador is always made up of iron content only, internal as well as external particles. But nowadays, compared to Maruti Suzuki, that all the Maruti products are giving non-metallic in nature or non-ionic nature. Instead of that, they are made up of plastic content. If any crashes, small crashes available, all the particles are crushed and they are giving us a very more damage nature. But in the case of if it is happening in iron, it won't be affect easily, won't be damaged very easily. But the main purpose to improve their performances. What type of performance we are expecting? We are means public expecting. Public always expects more and more. That is, with lowest fuel, I need to go more distance. So that particles are converted into some other thing that is a plastic nature. This is one of the examples. In household utensils as well as now itself changed to plastic nowadays. Another one, electronics. In once upon a time, in almost the electronic things are made up of ceramic materials. Now it has been changed from ceramic into plastic, sometimes composites. The composites are very composites materials are having more advantages compared to plastics. That's what the electronic compounds are made up of composites mostly because they are having a high stable at a higher temperature as well as they are having more electrical resistance just like insulator. This is also one of the reason we are going for composite protections. Is the regarding of your polymers and previously we saw about the boiler plate. Nowadays it is also made up of some kind of composite materials, but still it is going the work. It will be coming in our future. So everything are made up of simplest as well as lifetime should be increased. Now, in the third unit, we are having electrochemistry. So electrochemistry is nothing the combination of chemistry and electrical field. It is always used in industrial region. In industry sectors, they are having lot of separate plants to segregate the materials for their main production. For example, we may consider one of the industry to produce the copper. For example, you may consider Sterlite Industries, which is available in Tuticorin. Here, they produce the copper as a main product. That is a major product. Not only that, copper is a product. Apart from copper, they are producing slime, gold, and so on. So, say those type of industries are always following electrochemical process. So electrochemical process, it means they are using the technique which is optable to separate materials. For copper, for protection of copper, the copper, where is copper available? So all the metals, materials, non-metals available in our earth particles. So earth itself, that is only in the sand. The sand itself, it is having a lot of materials. Even gold also available in sand. For example, you may consider KGF. There are more content of gold available. How they are going to segregate it? Is it possible to adding the chemical one by one and removing? No, this is impossible. For that purpose, we need dissociation process, especially for electrolysis process. There, with the help of electrodes, easily compounds can be segregated. It needs small spaces. I am telling about the industries. If you are going for some other process, apart from the electrolysis process, if you are using some other hydrolysis process or any other chemical process, it needs more and more spaces. So all the industries are always using only the electrochemical process for their separation. There, one of the advantages, the segregation process is very simplest nature. Another one, it is almost giving 99.9% of purest nature. If you are using the chemical process, it won't give that much of purest nature of separation. That's what the electrochemical process is always preferable in almost all the industries. And another one, nowadays the storage devices, batteries and capacitors, super capacitors. So once upon a time we use the batteries in our life. Nowadays it has all the people lifestyle has been changed. So instead of using battery, capacitors are implemented. And now again it is giving in the name of supercapacitors. So supercapacitors is nothing, this is just like a battery, but they are having more stability nature compared to battery. So everything is a storage devices only. Battery can itself, it will store some kind of electricity, but compared to supercapacity, the storage content of electricity are very less. But in the case of super capacity, it is having more capable to save more quantity. And one more thing, to recharge the battery, it is taking long time. But in the case of super capacitor, it is having very shortest time. To reduce the time concern, the storage devices also change. In batteries also, most of the polymer as well as composites are using. Plastic as well as composites. So everything's are interlocking, interlinking to produce the product in this world. So electrochemistry itself, it is not only used for separation process, and also it is used as one of the storage devices like batteries. There also electrochemical processes are available, are applicable. The basic principle, when the chemical energy converted into electrical energy or the electrical energy is converted into chemical energy, both the processes are applicable in that battery. When it is charging, that time the reverse process, electrical energy converted into chemical energy. When it is using, that is direct process, chemical energies are converted into electrical energy. Chemicals are react each other, then they are producing the electricity. That electricity is directly extracted by our human being, then they are using. I think time is 1:30. Your faculty members are asking me to complete before 1:30. I use more time. Anyways, thank you for your attention. Wish you all the best.